In this video, we're going to look at questions 5 through 8 on the 5.2 worksheet for it. And we'll start with question 5. Now, just like in the previous video with question 4, I'm going to do something a little controversial, is I'm going to work on both sides of the equation. Let's simplify the left side first. And again, we're trying to talk about all the themes that we start to notice is there's all multiplication on the left side, which means I can cross out common factors in the top and the bottom. So they both have a sine of x, so I can cross them out. The bottom has a cosine squared of x, while the top has a cosine cubed. So two of these three can cancel out, and I'm left with just cosine of x. So that left side wasn't that bad to simplify for it. So what we're going to do is now we're going to simplify the right-hand side. And it kind of helps me to know I want cosine of x for it. But the problem is I see a tangent here, and that's not helpful. So just like before, I want common terms. And since I see a cosine, I'm going to change to sines and cosines on the right-hand side. So tangent of x, I'm going to write it as sine of x over cosine of x. And we can keep going. The left-hand side is going to stay my cosine of x. And again, notice I am dividing by a fraction. There's another repetitive theme we've seen from the previous video is dividing by a fraction means I'm going to flip the denominator and I'm going to multiply. So I'm going to multiply sine of x by cosine x over sine of x. And if it makes you feel better to put the sine of x over 1, go ahead. And so my left-hand side is great. I kept it as cosine of x. It's simple. And look at that. It's another theme that we've had before. Is I am doing all multiplication here. And so I can cross out common factors in the top and bottom. So the sine of x cancels and I'm left with cosine of x. Pretty straightforward approach. We worked on both sides in this example, but the themes were still there. When you're doing all multiplication, you can cross out common factors. Dividing by a fraction is in that problem as well. So that's a pretty good one. Pretty simple when it comes to the approach. But number 6 is a little more complicated. So for number 6, what I'm going to do, and there are some things in this one that's going to be weird for us, so we're going to talk through it more and realize we may not know the exact approach off the top of our head, but there's concepts here for us to learn. I'm going to keep the left-hand side. And for the right-hand side, I'm going to notice I have cosecant and cotangent. Those aren't similar terms. But yet on the left side, I have cosines. And so that tells me my first step is going to be to create my common terms. I'm going to change everything on the right side to sines and cosines. So we see that theme up here. So cosecant of x is 1 over sine of x. And then cotangent of x is cosine of x over sine of x. So I have common terms, really helpful. And at this point, notice I have a fraction minus a fraction. Again, a theme that's repeating is that if I am adding or subtracting two fractions together, I want a common denominator. And in this case, you already have one. It was sine of x. So I'm just going to merge the top together, become 1 minus cosine of x over sine of x. My left side stayed the same. So that one we see repetitive from previous examples on 1 through 4, and now we wonder, well, what's the next step? So I got there, what do I do? And I always pause and kind of take a look at what I'm given and what I want to find. I want a 1 minus cosine of x on top. Notice I do have that on top already, so my mind's going, that's a good thing. The numerator's nice. The only problem I see is it's squared, and I don't like that. So something's going to have to happen to simplify that. And I want a 1 minus cosine x on the bottom. I have a sine x, so that doesn't work either. So I see there's one good thing right now, but there's two things I need to fix. And the question is going to be, how do I do that? Well, the left side's going to stay the same. And since I'm squaring a fraction, what I'm going to do is I'm going to try and simplify, which means I'm going to take that squared and split it across the top and the bottom, because then I can simplify both those terms separately. And I still see I have that 1 minus cosine of x that I want on the top. So I still see I have this and this on the numerators. So let's take a look. What we're going to do next is how do I simplify it? So we're going to simplify the top and the bottom separate. The top, since I want to keep the 1 minus cosine of x, what I'm going to do is I am going to look at what does it mean to square something. And it means to multiply it by itself. And again, notice that didn't change what I wanted. I still have a 1 minus cosine of x visible, which is a good thing. I didn't get rid of what I'm trying to create. I'm keeping it through my simplification process. So that's a concept we know we haven't seen too much. So that's something new to kind of focus on, is sometimes you can square something by just writing it out twice with the trig functions and leaving it to hopefully in factor form may help us. Now the new concept is right here. I want in the denominator a cosine, and the problem is I have a sine, and I need to make it a cosine. And what we're going to do is we are going to kind of do a reverse of our usual Pythagorean identity. Is normally when we have Pythagorean identity, we kind of go from 2 terms down to 1 term. What I'm going to do is I am going to change sine squared based off of our formulas into 1 minus cosine squared of x. That allows me to create all cosines. So this is new. We haven't really gone backwards with our Pythagorean identities. We've always gone in a way forward. We've always condensed. I'm asking us to expand in this problem. And the reason why is because it gets me a common trig ratio. I don't want sine, I want cosine. And by doing that, I get cosine. And the other reason why is something that is pretty hard to see here in the beginning. And that's that when you have a minus sign with your Pythagorean identities, there's a very good chance you're looking at a difference of squares factoring technique. You know, we know x squared minus 25 can factor into x plus 5, x minus 5. That if you're subtracting 2 perfect squares, you can do the sum and difference of the square roots in factored form. And this is something you kind of have to learn, you don't know yet, is you can take your Pythagorean identity and we can factor it between different squares. So the left side, I'm keeping 1 minus cosine of x over 1 plus cosine of x. And one of the reasons why I want to do that approach is because if I can factor using my difference of squares, the square root of 1 is 1, and the square root of cosine of x is, cosine squared of x is cosine of x. So I have 1 plus cosine of x and 1 minus cosine of x. Same structure here, 1 plus, 1 minus, and you're dealing with the square roots. And by doing this, I see I have a common factor on top and a common factor on bottom. So this problem, number 6, was probably one of the most complicated ones we're dealing with. So I finally have what I was looking for since the common factor is crossed out. 1 minus cosine of x over 1 plus cosine of x. Q, E, E. It was complicated because of, I would say, these 2 steps. So I don't expect this one to be from your memory, something you just get by instinct. It's a teaching problem. It's meant to help you see is sometimes if it's needed, you can do the reverse of your Pythagorean identities. What tells you? How do I know? And again, that's something you have to kind of start to notice is I have one term that is not the right trig function. So I'm going to try and create it. And that's why I use the reverse of the Pythagorean identity. And this one is just by recognizing now is something to keep in the back of your mind is your Pythagorean identities that involve a minus sign. Those can be factored using your difference of squares factoring techniques, in which will allow us to kind of, in a way, cross out common factors if there's multiplication. So that's new to us. So number 6, that's unique, I would say. that problem was more of a teaching problem to go through rather than a you better get that on your own. Number 7. This one really relates to a problem that we did on the notes. I'm going to keep the left side. And I'm not going to change anything about it. I'm not going to go to sines and cosines. I'm going to keep it as tangent of x on the bottom, secant of x plus 1 on the top. I'll change the right-hand side. So I'm going to change my tangent of x, and I'm going to change my secant of x minus 1 side. But notice I didn't do that yet. I really copied down the problem again, and there's a reason why. Is before I start, it's a puzzle. I want to look at it. I want to see what's going on. And so I look at it, and I notice I want a tangent of x in the bottom. Unfortunately, it's on the top in number 7. So that's not good, but I at least know I have the trig ratio I want, so I'm not going to change it. I just need to find a way to put it on the other side. So hopefully that happens. And I notice this. I have a secant of x in a 1. I have a secant of x in a 1. That's also really nice. The problem, though, is this is a plus 1 and this is a minus 1. And that should bother you that they're not the same. And they're also on the wrong sides. And so this is where definitions and terminology comes important and plays a big role, is when you have the same terms and the opposite operation in between them, we call those conjugates, and we use them for rationalizing. And in this case, we can use it to take care of that secant of x minus 1 in the bottom. And so I'm going to multiply by a clever form of 1. Again, I see a lot of binomials. I'm going to put them in parentheses so I understand the distributing. And that is amazing to happen because I get the idea of conjugates and the definition is there. And by using it, notice what I get in the numerator. What I get in the numerator for this is I get my secant of x plus 1, which is exactly what I want in the numerator. So the definition of conjugates tells us that we can create it in the numerator denominator to help us out. And so now it's kind of like, well, what do I do? Do I distribute? Because other times you distribute. Do we do it here? And the answer is no, you don't. Well, how do you know that? And again, these are the questions you need to figure out through the patterns. And how I know I'm not going to distribute, that when I write the right-hand side, I'm going to leave the top in factored form, is because what's in the top? In the numerator is my secant of x plus 1, which is exactly what I wanted. So I'm not going to change that. So there's a reason why we don't distribute in the top. Now I'm going to distribute in the bottom. And the reason why is because I want my tangent of x, and I don't have it by leaving it in factored form. So hopefully by distributing, I'll be able to simplify and create it somehow. So remember, when you are distributing conjugates, you're really dealing with is difference of squares. I mean, a minus b, a plus b is the factor form of a squared minus b squared. I can square my first term, secant squared of x, and square my second term, 1, and it's the difference of squares. You could also distribute and see that the middle terms are going to cancel. Well, what's interesting about this? My left-hand side is still the same. I took care of that secant of x plus 1, which makes me happy that I don't have to worry about that. But I still have this tangent of x in the top that I don't like. I'm not going to change, and I'll highlight it again to help us. I'm not going to change this. I want that. I'm keeping that. I don't want secant squared of x minus 1. I mean, I want a tangent there, so that denominator bothers me. But again, I see that denominator, I see a square trig ratio and the number 1, and it makes me question, is that a Pythagorean identity, secant squared of x minus 1? And it is. It's tangent squared of x. So notice now I have a tangent on the bottom, which is exactly what I wanted, which is great. And so the left side is secant x plus 1 over tangent x. Haven't changed it yet. And what can I do on the right side? Well, I'm going to keep that secant of x plus 1. That was nice. But notice what's going on. It's all multiplication on top. So I can cross out common factors in the numerator and denominator. Again, a common theme from our previous videos and problems. And I'm left with just a tangent of x in the bottom. So now if I look at it, the left-hand side equals the right-hand side. QED. It has been demonstrated. We have proven that secant of x plus 1 is equal to tangent of x over secant of x minus 1. Well, what about this problem? How are we supposed to know this? What steps, what concepts do we have here? How are they similar to what we learned? Well, conjugates is new. And that's based off of the definition of conjugates for us. And I knew to do conjugates because of the structure of the original problem. And this is where you have to get familiar with structures, with verified trig identities. Is you had the same trig ratios and the same numbers, secant of x and of 1, they were opposite operations. Right away, that's the definition of conjugate. So that kind of tells me my first step. And then as we go, we're starting to notice that if I create what I want, I'm probably not going to distribute into it because then I'm ruining all the work I did. And we're starting to see that if we have square trig ratios with the number 1, they're most likely going to factor into a Pythagorean identity. And we're also seeing that when we have all multiplication, that we can cross out common factors in the top and the bottom. So there are some hidden themes that are repeating. So let's take a look at number 8. Number 8 is a little unique for this one as well. And what am I going to do? Well, which side is simpler? And some people want to say that the left side, they're tempted to say it's simpler because of sines and cosines. And I beg to differ on that one because it's fourth power. And I don't know about you, but I don't want to work with fourth powers. I don't want to make everything into a fourth power. It's going to be complicated. So to me, the left side is more complicated than the right side. So I'm going to keep the right-hand side. I'm going to keep my 1 minus cotangent squared of x. And what I'm going to do is I'm going to change my left-hand side. How am I going to do that is based off of, well, I like the denominator. That's simple. So let's just do that first. I don't like the numerator. Sine to the fourth power of x minus cosine to the fourth power of x. Again, what do? Well, you haven't seen that in this form very often, but I do know we've done it this way before in pre-calculus is we've dealt with this, x to the fourth minus 81. And again, this was a difference of squares factoring technique. We would factor it into x squared plus 9 and x squared minus 9. And it's the same right here. These are perfect squares for us. I might want to extend my fraction bar so I can write the whole thing on there. Is sine to the fourth power is sine squared of x squared. So I'm going to write this as sine of x, sine squared of x, plus cosine squared of x, times sine squared of x minus cosine squared of x. And that's using my difference of squares factoring technique. Well, why is this helpful? And again, we got to take a look, is we don't like fourth powers, but we know fourth powers are the squares of squared terms. And so I'm going to bring it down. And that's nice because one, start to see I'm getting the squared that I want. Now, granted, it's not cotangent squared, but I do have the right exponent now. So I can think I'm on the right track. So what I'm going to do is I'm going to break it down even further. Let's take a look at the first parentheses. Sine squared of x plus cosine squared of x. Again, you have square trig ratios. There's a chance it's going to be a Pythagorean identity. And really it is. Sine squared plus cosine squared is 1. So sine squared of x plus cosine squared of x is 1. However, you may be tempted to look like, what about this one? This one has to be a trig ratio. One of our Pythagorean identities. And it's not, actually. It's not a Pythagorean identity. So we're going to leave it as sine squared of x minus cosine squared of x. And let's just see what happens. And I'm not going to change the bottom because it's already in simple form for us. We're not going to make it any harder than we need to down there. Well, multiply by 1 doesn't change anything. So let's just get rid of that 1 in the parentheses. And so that's not bad. Well, let's look at this. What do I do next? I want two terms. I want a 1 and I want a cotangent squared. So I'm not even in the right terms because I have sines and cosines. But if I take a look at a few things, I can see that if I were to pair these two together, let's put that fraction bar back. If I were to pair these two together, sine squared of x over sine squared of x, I would get that 1. So that's pretty nice if I look at it. And if I pair these two together, cosine squared of x over sine squared of x, well, cosine of x over sine of x is cotangent. So that's good. So what I'm going to do, I'm going to split the numerator over the denominator. I'm going to write them so they're two fractions with the same denominator, unmerge them, expand them out. And the reason why is because now I can see I have sine squared of x divided by sine squared of x. That's 1, which is exactly what I wanted on the right-hand side. And I have minus, so that's good. And the next part is cosine squared of x over sine squared of x. Well, that's cotangent squared of x, which is exactly what I want. And so it has been demonstrated. QED. We have proven that the left-hand side equals the right-hand side. So what technique here is we have a difference of squares, which is a new structure compared to what we've had before. And we've looked at, it's not only about merging common denominators together, we can also expand them apart on it. And when do I know that is based off of what does my side that I'm keeping look like. And since I had two terms there, and I had two terms on the top, I knew I should probably separate it, and that would create the format I wanted. So that is problems 5 through 8 for us. Hopefully it helps your understanding of the concepts behind them, some of the repeating themes, and you can watch the next videos for it where we will go over problems 9 through 12.